Okay, we come to the next section of electricity, the basic one, the basic electricity. Now, today topic will be on the third component, the resistance. Okay, the third component of a circuit. We'll look at what is actually resistance and what factors affects the resistance of the circuit. Okay, now let me refer to the slides. Hey, give me a minute. Okay, the one that you are looking at here is the resistance. Okay, now there are different definitions, but in general, all definitions usually revolve around the same idea, whereby it's actually the measure of resistance is actually it's a ratio. It's a ratio of the two previous components that we mentioned about, the potential difference and the current flowing through the component itself. Now, loosely defined in terms of MAP is actually voltage divided by current. Okay, here this is what we call the potential difference of the component and the current flowing through the component. So you'll find that resistance of component actually involves two party, and the potential difference that flowing through it itself, the potential difference across itself and the current flowing through it. So when you look at the ratio of these two components, you actually have a number, and that number is actually the measure of the resistance. And the unit is called ohms. Now, later on in the next few slides, you look at what actually is resistance other than the mathematical presentations. Okay. Now, the circuits that use for measuring resistance, okay, we look at is because we need two components. We need V and we need R. Okay, we need V and I so that we can actually calculate resistance using the mathematical formula. So which means your circuit actually needs to have to be able to measure the two components, namely the voltage and the current itself. So how do you measure the thing is, okay, same thing as before. Okay, I will need you all to actually insert the measurements, the meter, whatever relevant meters that we have. For example, if I need a current, I will actually have the ammeter here. This ammeter actually measures the current. Okay, it measures the current for this guy. Okay, so you need this equipment here. If I have the voltmeter, I will actually this is what we call the voltmeter. You actually measure the potential difference of the device itself or the component itself. Okay, same thing, voltmeter is in parallel, what we call up and down formation. Okay, up and down formation. In ammeter, same thing is in series, it's always side by side. Okay, side by side to the component itself. Okay, so this is and once let's say you switch on the circuit, you'll be able to get the two readings here. You record down and use the formula R equal to V over I, mathematical formula, and you'll be able to calculate the resistance of the component itself. Okay, so this is what I mentioned. Okay, there are different type of resistors. Okay, resistors, there are two of them. In general, you have what you call the fixed resistor, which has a certain number based on the market demand on this thing. So once you buy the resistor, which look like this, where the number is fixed, and you will actually solder it to your circuit. The other type of resistor that we have is actually the rheostat, the variable resistor. This design of variable resistor is slightly different from the market, from the industry, because this one is generally for school use. It's meant to be more rugged. And so what the kids do is they will actually slide this guy up and down. Okay, so the current will actually flow from one side, flow here, entering the cable here, after that exit, and exit from here. So by varying this pulley left and right, I'm actually changing the length of the cable, changing the resistance in the rheostat. Okay, and after that, I can affect the current flowing through the resistance. One of the common thing that you have to remember is, or you have to understand, is that when I say resistance, resistor, the resistance inside a resistor, what does it resist? Okay, in the fact that resistor and current, they have an inverse relationship, whereby the higher the resistance, the lower is the current. So when we talk about resistance, when the word resistance, okay, the word resist, I actually loosely refer it to I resist current. Okay, so the higher the resistance means the higher my resistance to current, the lesser I will allow current to flow through the wire itself. Okay, so the higher the resistance, the lower the current. So this is the relationship that we have. Okay, and it's a simple one. Okay, resistance here for now is like the idea of resistance. Actually, the idea is the fact that it actually is a value of the component itself, and what it does is it actually usually what we call it actually jam it or jam the current from coming in. It actually reduces the current. If I increase the resistance, I will actually reduce the current flowing through the circuit itself. Okay, now what factors affect resistance? Okay, so one of the common thing that we have is actually resistivity. Now, resistivity is actually the characteristic of the wire itself or the component itself. Okay, because the component itself actually, the component resistance is actually dependent on several factors, and they are namely the length of the component, the cross-sectional area of the component, and the material, the resistivity of the material itself. So which means the resistance, okay, in the summary, okay, your resistance will affect your current. Okay, so what we have is the higher the resistance, the lower the current. So what factors affect your resistance so that you can actually affect your current directly? So the component that we mentioned here is all these three: your length, okay, your area, and the resistivity, the type of material. So by changing these three, your resistance will change. And how they are affected, they are actually controlled by the formula here. Okay, so we can actually loosely saying that your resistance, okay, increases when the length of the cable increase, or the area of the cross-sectional area decreases, or I can say the material changes, the resistivity increases. Okay, so I resist. So end of the day, any three of these factors changes together or individually, you'll find that the resistance will change, vice versa. Okay. Now, this is what we mean by the formulas. Resistivity. Resistivity, like I mentioned before, is the type of material. It will actually control the type of material or the type of conductor. Okay, because resistivity is of a component is actually is actually quite unique to each of the character or each of the component, each of the conductor itself. Okay, and same thing like all the units you have, they are all in SI unit. Okay, resistivity, the unit for this is ohm meter. Area here we are looking out for is meter square. L here, length here, if you're looking out for is length, is in meter. So once all the three components are in SI unit, you'll find that the resistance formula will be ohms, the SI unit for resistance. Okay. Now, here, same thing like I mentioned, the resistivity is actually the characteristics or the ID of the material. Every material here will have a unique resistivity. And of course, you actually don't need to memorize all this. Okay, even in industry, in those electrician, those expert engineers, they actually don't remember the resistivity. What they do, they will just, if they need the resistivity, they will actually just Google for it online, or they refer to their book of constants, whereby all these factors are actually inside the book. Okay, so if you look at the formula here, the lower the resistivity, the better is the conductors. Okay, so normally what we have is the best conductor or the good conductors, the best of the best. Okay, the resistivity will actually be the lowest. Those insulator, or what we call the bad conductor of electricity, okay, you'll find that the resistivity itself actually is very big. It can be like easily 10 to the power 16, 19, or even 22. Well, it's quite high one. Okay. Now, common questions that we look at, okay, if you look at it mathematically, we actually revolve around the formula R equal to rho L over A, okay, the resistivity formula. Okay, we make use of this formula to look at, to solve questions mathematically, to decide, actually, we can use it to decide how long, how thick the cable I want, or even what type of material I want, because inherently, the amount of resistance I want in a circuit based on my setup is actually limited, or is actually predetermined based on my needs for the circuit itself. Okay. Now, So for this question that we have a length of resistance which is 50 cm. Is connected to a battery and is the ammeter read 0.15. So if you look at it in the sense that if you look at the circuit, it actually has a 3-volt battery. So the cable is actually, so it could be something like this. Okay, so this could be the cable I want. Okay, this could be the cable that I'm talking about. Okay, and I have an ammeter reading. Ammeter reading, remember, is always beside the component. So the ammeter reading will be here, beside the component. So the ammeter reading will actually read 0.15. Okay, so this is the battery itself. So this is plus and minus. So based on the question, this is a 3-volt circuit with 3-volt battery, and the current will go from plus to minus, and it will actually read 0.15. So this will be your current 0.15 ampere. Okay, so this could be the circuit that you're looking for. So so here what we have is quite straightforward. The cable is actually 3 volts, then the current flowing through the cable is 0.15. Okay, common formula that we're looking at, it will be this. Okay, or it could be common two formula that we look at is R equal to, give me a minute. Okay, other than resistivity formulas, we actually has two other formulas. Okay, so where they are. Okay, so other than this formula, I equal to rho L over A, I have the formula for current I mentioned in the previous video. Current is actually Q over T. Thereafter, I have a potential difference, or the EMF formula, which is equal to energy, work done, divided by charge. Okay, so these are the two formulas that we are looking for. Okay, 1, 2, and the third one here. Okay, so these are three formulas that you can use it, or possibly there might be a need to use it, okay, to solve A, B, and C. Okay, so now let's take a look at the answer or the solution. Okay, so if I want the resistance, of the component, I will just use the formula R equal to V over I, because I already got the component itself. Yeah, I got the voltage, I got the current, so I just substitute into using the formula. I should have the resistance of the cable now. Okay, so this is what happened. Okay, so this will be the formula. Now, same thing what happened is based on this resistance here, based on the question here. Okay, this question here actually look at another aspect, which means I have another case, another scenario whereby actually the cable actually doubled, the length doubled, the area half. Okay, so how does this work? Is this particular resistance cable, okay, at R equal 20, it actually has certain length, it actually has certain cross-sectional area. Okay, so when it has a certain length, certain area, and a certain material, okay, so when these three, okay, it will actually give rise to a resistance of L over A. Okay, now the question now they tell you is, I have another cable, the same material, okay, with the same cable now, okay, with the same cable. But right now is this R2, the length has doubled. Okay, so what I'm doing now is I have R2, which is rho L2 over A2. Okay, so L2 now is actually 2 times L1 because the question said length has doubled. Okay, because based on the questions, L2 length is actually double of L1. So what I do is I will just replace it to L1. Area, the questions mentioned the cable A2. The area is actually half of A1. Okay, this area is actually half of A1. Length is actually twice of L1. So what I do is now I will substitute back the equations. Okay, I will have this. Okay, so what you are doing here now is this. Okay, from this step before I arrive here is I actually do a bit of simple manipulation. So you end up with R2 is equal to, okay, 4 times K L1 over A1. Okay, and you'll find that, okay, K L1 A1 is actually 20 ohm. Because this is actually resistance 1. Because resistance 1, I mentioned the last lesson, previous example is 20 ohms. And the formula is rho L over A, which is L1 and A1. Okay, so actually is 4 times R1. Okay, so R2 is actually 4 times R1, which is 4 times 20, which will give you back 80. So this will give you back 80. And after that, how do I find the current? I'll use the formula voltage over resistance is voltage over current. Okay, so I want to find current. I rearrange. I will have voltage 3. Resistance is 80 ohms. I will get the current to be 0.0375 M itself. Okay, so this is how I look at the math. So when you look at the math involved, it's a bit complicated in the sense that the formulas are quite fixed. But because of the manipulation, I have this thing called case 1 and case 2. So it can be a bit complicated. Okay, but it's quite easy if you look at it. It's quite straightforward in the sense that the answers, the formulas that we are always using. Okay, the formulas that we're only using R over VI, R equal to rho L over A. Okay, we are only using these two formulas only. Okay, then maybe sometimes I will use voltage equal to energy divided by charge, or sometimes I will use current equal to Q over T. Okay, so inherently there's actually like 4 formulas that we are looking for. Okay, these are the 4 that I mentioned before: 1, 2, 3, 4. Okay, and the manipulation that we are looking out for is sometimes when I look at rho L over A, this formula, I have this case 2, I have this case 1 scenario. So what you are trying to do when you look at solving for case 1 and case 2 is you actually trying to make case 2, okay, to be represented in terms of case 1, like 4R1 or this thing, by substituting the condition given by the question here. Okay, so this is the mathematical formula. Okay, so later on, if this is still a bit confusing, maybe later on you can just re-watch this section to look at the math itself. Okay, once you know about the math, the question is actually quite repetitive. It's actually quite boring in the sense. It's quite simple lah. Okay, so if you need to later on after this the video, please rewind the video to this particular section. Then after re-watch it again. Okay, then after that, the last part that we are looking out for, so sorry about it. Let me erase the thing. Okay, now the last part that we are looking out for is the resistance, maybe it's the resistivity. Okay, the resistivity of the cable. So same thing, R rho L over A. Okay, you rearrange the formulas to get back the answer that you want. Okay, so what you need is rearrange this formula, okay, to find the resistivity. So after that, what you do, you substitute back again. So simple formula like area. Area is pi r square. This one must know basic math. Okay, basic math, area of square, area of circle, triangle, trapezium, all this you need to know if for in terms of physics, the mathematics in physics. Okay. The last sections in terms of circuits, these are the symbols that we tend to use. Okay, so just run through them and be clear with the symbols when you use it. It's actually quite the same as what you learn in your grade 7, grade 8, or what you call sec 1 and sec 2. Okay. Interpreting of circuits diagram, open circuit, this one I would say is quite straightforward. Okay, if open means no current. Okay, then the other one that we have most commonly is the what we call there's a bypass cable, or what we call a short circuit. This is what we call a short circuit. Okay, so now short circuit, what you do is the current, instead of flowing through the cable now, through the light bulb now the current will actually travel across the light bulb here. Okay, why? Because let's say this light bulb has a certain resistance. Okay, but short circuit wise for this cable here, the resistance is almost 0. So you'll find that the relationship in the previous slides we mentioned, high resistance, low current. So the reverse will be true. If your resistance is super low, my current will be super high. So which means if you have a short circuit, which is a piece of wire, okay, in general, what we call a piece of wire, okay, the resistance of the wire is almost 0. It's almost 0 ohms. Okay, so which means the current that flowing through this cable is actually very large, or to be exact, is that the current will actually want to flow through this cable. Okay, they will not want to flow through this because this cable here is a short circuit resistance with lowest resistance, or to be exact, with 0 resistance. All my current will actually flow here, will decide to take on this path, the less difficult path, okay, and will actually bypass what we call the light bulb itself. And because of that, the light bulb will be shorted. Okay, so this is what I mean by a short circuit. A short circuit, later on we look at, is actually quite dangerous. Okay, so these are the components that we look at. So in a nutshell, we talk about what is current, what is voltage, and what is resistance in component, in the respective things, and we look at the math and the explanations for each of the component. Okay, at any one point, if you are confused about the mathematics, please scroll back to that particular section and take a look at it, because you need to be sure of these three components before we can move on to the next topic, which we look at how these three components can be rearranged in different formation, series or parallel, to get maybe the values that you want, or to solve certain circuits questions. Okay, if not, okay, that's all for this particular lessons. Any questions you have, you can leave it at the comments. Okay, then I'll just take a look and try to answer it as best as possible. Any feedback, by all means, leave it there, and I will try to read, and I will try to improve on it. Okay, if not, okay, remember to subscribe to the video to get to the latest update for my channel for the topics that you need. Okay, if not, thank you very much.